Reversing a linked list is a commonly asked coding interview question, and I know a lot of people who have been asked this question in Facebook and Google coding interviews. In this video we will go over a simple solution, and then we will see why it is not a good solution, and then we will get into a better and faster solution. So as input we get a linked list which consists of a bunch of nodes, and each node has a pointer to the next node, and in this way they form a list. And the goal is to reverse this linked list, so to create a new list that starts at 5 and ends at 1. So this new reversed linked list will look like this. So our recursive simple solution will be a recursive function that as input gets a linked list and the starting node of that linked list, and it will return the new starting node. So if we want to reverse this linked list, the input will be this node, and it will return the new starting node of the reversed linked list, so it will return the last node of the original list. So to do this, we will first do an input check. So this is really good practice. If you work on coding interviews, you should always check if the input is valid input. So if the node is not a real node, it is a non-value, for example, we will also return none. In the second step, we will go to the base case, and that is if a linked list is of size 1, so the node has no next node, we cannot really reverse it, so we will just return that node, because the reverse of a linked list of size 1 will also be that same linked list. And in the second step, we will do the recursive step. And that recursive step requires that we will reverse the linked list starting at the next node, and then we will append our current node to that reversed linked list. So for example, if our current node is the node with value 2, we will reverse the node starting at value 3. So node.next is the node with value 3, and we will reverse this whole part. So when the function returns, we will have reversed that linked list, and it will return the new starting point. So it will return the node with value 5 as new starting point. And then in the next step, we know that the new ending point of that reversed linked list will be node.next. So it will be the node with value 3. And our current node is still pointing to node.next. So we will remove that pointer, and we will let the new reversed linked list we will append the node to the new reversed linked list. So we will let node.next point to the new node, to node. We will set the new end. We will let new end point to node, and in this way, the node is appended to the reversed linked list. So it will look like this. And then at the end of the function, our function will return new.start. So it will return the starting point of the reversed linked list. So now we have reversed the linked list starting at node, which is the node with value 2, and ending at the node with value 5, and we will return the new starting point, which is the node with value 5. Now this is not a very good solution because we do a lot of function calls, and for each function call the current variables and the program counter and so on need to be saved on the stack. So when we do an initial function call, we will save some information on the stack, and in that initial function call even more information needs to be saved on the stack, and another function call is done, so even more information, and so on. So for each function call, information needs to be saved on the stack. So if we do a lot of function calls, we will run out of memory. So if the linked list is very long, a lot of function calls will happen, and thus we will have a lot of function calls and we will run out of memory and our program will crash. So we want to avoid this, and to do this we will need a better solution, a solution that does not this many function calls and that doesn't use a recursion. The iterative solution will create a function that does not do this many function calls and that gets as input also the first node of the linked list, and it will also return the new first node of the reversed linked list. I will first go over the code and then I will show it and explain it in more detail by a very clear example. So if you don't understand it immediately, just wait until I explain the full algorithm with an example. So we will say that the current value, we will create a new variable, current, and that is the first, that will equal the first variable of the linked list. And we will say that the previous value will equal none. So the current value will be the first element of the linked list, and the first element doesn't have a previous element, so we will say that previous equals none. Then we will have a loop, and in that loop we will say that current, as long as current is different from none, we will create a new temporary variable in which we save the next value. So we will save the next value in that temporary variable, and we will then say that the next value of the current element equals the previous element. So our current element will point to its previous element. So we will reverse that part of the linked list. We will reverse it by letting the element point to its previous element. I will explain this in more detail in an example. And then after we reversed, we let it, the node point to the previous node, we will say that the previous node will be the new current node, and the current node will be the next node which we saved in the temporary variable. And this loop will continue as long as there is a current node, and when we don't have a current node, we reach the end of the linked list and we can return the previous node. So I will now explain this with an example. Initially, the current node will be the first node of the linked list, and the current node has no previous node, so we will say that the previous node is none. We will then save the next node in a temporary variable, and we will let the current node point to its previous node. But since the first node has no previous node, we will just remove the pointer by setting it to none, since previous has the value of none initially. Then we will say that the previous node is now the current node, and the new current node will be the next node, so the temporary value which we saved earlier on. And then our loop continues and we do the loop again, and we'll say that, okay, we will again save the next node in a temporary variable. We will let the current node point to the previous node, and then we will say again that the previous node is the current node, and the current node will be the temporary variable or the node which we saved in the temporary variable. And this will continue until we reach the end of the linked list and current will equal none. We will get out of the loop and we will return the previous variable. So we will return the node with value 5. So the time complexity for this solution is O(n). We go over all nodes only once, and when we went over all nodes, we just return the last node, and we do this only once. Then there's also no additional memory needed for function calls, or no stack space is needed to do function calls, because there is only one function call, and that is when you call this function. So in this case, we have a very good, robust, iterative solution that only goes over the linked list once and reverses the linked list while doing this.